everybody. In this video I will solve some problems related with the topics of this week. First of all, I will find the equation of the tangent line and the equation of the normal line of the surface given with this equation and at this point. But to do this, first of all, we need to calculate gradient vector, if you remember, because the gradient vector of f evaluated at the given point is the normal vector of the tangent plane and also direction vector of the normal line. So to do this, first of all, we should define the function which gives the given surface, and I will take this constant to this side to obtain my equation. Okay, so now I can calculate the gradient f, and all we know that the components are the first partial derivatives of f with respect to x, y, and z respectively. So the first derivative of f with respect to x is 2x because y and z are constant in this case. And the first partial derivative of f with respect to y is 4y. And for this time x and z are constants for us. And at the end, the partial derivative with respect to z is 6z. So here x, y, and this 9 are constants with respect to z. But this is not enough because we need to calculate our gradient f at the given point. So here x is 2, y is 1, and z is 1. So 2 times 2 is 4, and 4 times 1 is 4, and 6 times 1 is 6. So this is the gradient vector of the surface which defines the given surface and evaluated at the given point. Okay. So now it's time to calculate and find the equation of the tangent plane. So first of all, to find the equation of a plane, you need a point. And in this case, point is given as 2, 1, 1. And you need a normal vector. And we know that the normal vector of the tangent plane is the gradient vector of f evaluated at the point. And in the formula, components are ABC, so I write ABC here, and it equals 4, 4, 6. So using the formula, if you remember it, the equation of the tangent plane is a times x minus x0 plus b times y minus y0 and plus c times z minus z0 equals 0. Okay, so if you substitute everything here, you will obtain the following result. A is 4, 4, x minus x0 is 2, plus b is 4, y minus y0 is 1, plus c is 6, z minus z0 is 1. So I have 4x minus 8 plus 4y minus 4 plus 6z minus 6 equals 0. At the end, the equation of the tangent plane is 4x plus 4y plus 6z. Here I have minus 12 plus minus 6 is minus 18, so the result is 18 on the right hand side of the equation. Okay, so this is the equation of the tangent plane to the given surface at the point. Now let's find the normal line. Again, I need a point, and it is given as 2, 1, 1. And also I need a normal vector, sorry, not normal, direction vector. And we know that this direction vector is gradient f evaluated at 2, 1, 1, like in this case. So it is again ABC, which is 4, 4, 6. So using this, I can write the parametric equations of the normal line, which can be obtained using those formulas. X is x0 plus at, y is y0 plus bt, and z is z0 plus ct. So using this formula, I can obtain result. X0 is 2 plus a is 4, 40 y is y0 here, which is 1, plus b is 4, 40, and z is z0 is 1 plus 60. Okay, this is the equation, parametric equations for the normal line of the surface at the given point. Okay. Here again we want to find the tangent plane and the normal line to the given surface, and to do this, first of all, I will define my function f of x, y, z by taking the parts on the right hand side of the equality to the left. Z minus in the square root, I have x squared plus y squared equals 0. Okay, this defines the given surface. Okay, now it's time to calculate the gradient f, and it is f sub x, f sub y, and f sub z. So f sub x is derivative of this term with respect to x, so it is minus 2x over in the square root x squared plus y squared. Okay, if you calculate it, you will obtain this result, and minus 2y over in the square root x squared plus y squared is the f sub y, and the derivative of this function with respect to z is 1. Maybe I can show it here to you. Here we have x squared plus y squared to the power 1 over 2. Here we have minus sign. So the derivative will be minus 1 over 2 times x squared plus y squared to the power 3 over minus 1 over 2, sorry. 1 over 2 minus 1 is 1 over 2 times derivative of the inner term. Okay, so you can get the result using this derivative. And the second part, second component also has the same result. This and this part same, but the derivative of inner part with respect to y will be 2y. Okay, so let's calculate this gradient at a given point here, 3, 4, 5. So if you substitute 3, 4, 5 here, 3 squared plus 4 squared will be, I have minus 2 times 3 over in the square, 3 squared plus 4 squared, okay? And minus 2 times 4 over in the square, 3 squared plus 4 squared, and 1 here. So we have this, minus 6 over 5, minus 8 over 5, and 1. Okay. Sorry, there's a mistake here. We can cancel those x's, so there is no 2 here. Okay. There is no 2 and no 2, no 2 here, so we have 3 and 4. So I will write it one more time. We have minus 3 over 5, minus 4 over 5, and 1. This is the gradient vector evaluated at the given points. Okay, so now it's time to find the tangent, equation of the tangent plane. We know what is the point. Point is 3, 4, 5. And the normal vector, which is the gradient vector of f, evaluated at the given point. So it is ABC, which is minus 3 over 5, minus 4 over 5, and 1. Okay, now I can write the equation. And we know that the formula is a times x minus x0 plus b times y minus y0 plus c times z minus z0 equals 0. So I know what is a. A is minus 3 over 5 times x minus x0 is 3 plus minus 4 over 5, which is b times y minus y0 is 4 plus c is 1 and z minus 5 equals 0. Here we have, so the if you do the calculations here, then you will obtain minus 3x. If you substitute this, plus 9 over 5 minus 4y, let me write plus here, minus 4y plus 16 over 5 plus z minus 5 is 0. You can leave it like that, or you can distribute this 5, and if you distribute it, minus 3x plus 9 minus 4y plus 16 plus 5z minus 25 equals 0 you will have. So you have 9 plus 16, which is 25. 25 minus 25 is 0. So at the end I have this 3x minus 4y plus 5z equals 0. Okay. Or you can multiply it with the minus 1 and get the result 3x plus 4y minus 5z equals 0. This is the equation of the tangent line to the surface at the given point. So it's time to find the normal tangent plane, normal line equation. Again, I need a point here, and we know what is the point. Point is P0, X0, Y0, Z0, given as 3, 4, 5, and the direction vector is gradient f evaluated at P0, which is this, okay, this one. So again, I can write the equation using the formula. X is x0 plus at, y is y0 plus bt, and z is z0 plus ct. So we know what is x0. X0 is 3, and a is minus 3 over 5t. Okay, y equals 4 minus 4 over 5t, and z equals 5 plus t. So this is the equation of the tangent normal line to the surface at the given points. Okay. Now we are given a function f of xy, and we want to find and classify the critical points of this function. And to do this, we will use a second derivative test. And first of all, I will find the critical points of this function. If you remember, the step 1 is that, right? And in the step 1, to find the derivative critical points, we need to calculate first of all first partial derivatives, which is 3x squared minus 3, and f sub y is 3y squared minus 12. Okay, so if I equate these to 0, from the first part I have x squared minus 1 is 0. So x squared is 1, so x is minus 1 or x is 1. And here we have, if I take the common parentheses of the and then cancel it, y squared minus 4 is 0. So y squared is 4, which means y is minus 2 or y is 2. So we have 4 different critical points. When x is minus 1, y can be minus 2 or 2. When x is 1, y can be minus 2 or 2. These are critical points. Okay, so it's time to, now it's in step 2, we need to calculate a, b, c, and data. And we know that a, x, y is second derivative of f with respect to x. Let's evaluate the first derivative of f with respect to x to obtain this derivative. So I have 6x. Okay. bxy is f sub yy. So it is the second derivative of f with respect to y. So the first derivative of this function with respect to y, which is 6y. And cxy is f sub xy. So it is enough to calculate the derivative of this function with respect to y, which is 0. And delta xy is a times b minus c squared. So a is 6x, b is 6y minus 0 squared. So I have 36xy. Okay. Now I can classify my points, critical points. So to classify them, we do more black spots here. To classify them, I will start with the first point first of all, minus 1, minus 2, okay? And here, first of all, we need to calculate delta. Okay, delta minus 1 minus 2 is 36 times minus 1 minus 2, which is 72, and it is greater than 0. If delta is greater than 0, you should check the sign of a. And a minus 1 minus 2 is here minus 6, right? And it is less than 0. So we have this. F has a local maximum at minus 1, minus 2. Okay, so there is a local maximum here, and it occurs at minus 1, minus 2 points. Okay, so let's check the second point, which is minus 1, 2. Okay, minus 1, 2. And for this time, again, I will check my delta. Delta minus 1, 2 is 36 times minus 1 times 2, which is minus 72, which is less than 0. If it is less than 0, there is no need to check a, the sign of a. So here we can say that minus 1, 2 is a saddle point. Okay, so there is no local max or local min here. Okay, let's continue with the third point, which is 1 minus 2. Again, to calculate it, we will first of all, to classify it, we will first of all calculate the delta plus 1 minus 2. So we know that delta is 36xy, so 36x is 1, y is minus 2, which is minus 72, and it is again less than 0. So again, there is no need to check the sign of a. 1 minus 2 is a saddle point. So there is no local mean or local max at plus 1 minus 2 points. Okay, and we have one more point, which is 1, 2. To decide the type of this point, first of all, again, we will calculate delta, which is 36 times 1 times 2, and I have 72, which is greater than 0. So I need to check the sign of a here. Okay, and sign of a can be calculated. Formula of a, we know that formula of a is 6x, so 6 times 1, which is 6, and it is greater than 0. So because delta is greater than 0 and a is greater than 0, I can conclude that f has a local minimum at 1, 2. Okay. So we have one local maximum point, one local minimum point, and two saddle points here. Let's continue with the next problem. We are looking for the extreme values for this time, which means we are looking for the absolute minimum and absolute maximum. So if you remember it, we have again 3 steps here. First of all, we should calculate the critical points. And then we should analyze the boundary of the given region. And then we will make a table and decide the absolute minimum value and the absolute maximum value of the given function. So step 1, critical point. So to do this, I will again use first partial derivatives of the given function, and it is 2x and minus 2y. If I equate them to 0, I will see that 0, 0 is the only critical point here. But I have to check whether or not this point is in the given region. So to do this, I will substitute it in the equation, and I see that this point satisfies the given equation. So 0, 0 is in the given region. Okay. So because it is in the given region, we should consider this during the at the final step when we make the table. Okay. So step 2, boundary. I have a circle here, right? And the radius of this circle is square root of x. So this is a circle as a boundary, square root of 3, sorry, not x, and minus square root of 3 here. So this is our region. Okay, we have only one boundary, and the boundary is that circle, x squared plus y squared equals 3. And here, x changes between minus square root and square root of x, is 3. Okay, so using this equality and this interval, we will obtain a new function which depends on the x, and we will analyze critical points and endpoints of this function. Okay, so let's do it. First of all, I have f of xy equals x squared minus y squared, and on the other hand I have x squared plus y squared is 3. Okay, so if x squared plus y squared is 3, then y squared will be 3 minus x squared, right? And x squared is in this interval here, x. Okay, so I can replace this y squared with that number. So I have f of x y equals x squared minus 3 minus x squared, which means I have 2x squared minus 3. Okay, so I call this function g of x now. And we are on this interval. We have two endpoints and we need to find the critical point. To find the critical point, I will first of all evaluate the derivative of this function and then equate it to 0, which means x is 0. So x is 0 is critical point, x is minus square root of 3, and x is square root of 3 are endpoints. So when x is 0, using this equation, when x is 0, y squared equals 3 minus 0 squared, which is 3. So y can be equal to minus or plus square root of 3. We have 2 points from there. Okay, when x is minus or plus square root of 3, then y squared will be 3 minus or plus square root of 3 squared, which is 0. So y is 0. So the points are this. When x is 0, I have minus square root of 3. Also, it can be equal to square root of 3. And when x is minus square root of 3, y is 0. When x is square root of 3, also y is 0. So we have 4 points from on the boundary. The points are these. Okay. Square root of 3 is 0, minus square root of 3 is 0. And here we have 0 square root of 3, and here we have 0 minus square root of 3. Also, we have one more point, which is 0, 0. This is the critical point in the region. So using these points, I will make a table here. I will make a chart, step 3. And in this chart, we have xy and the function value of the, because we just want to calculate the value of the function at the obtained points, x squared minus y squared. And we know that first point is 0, 0, and the other points are there. Okay, I will write them in the table. 0, 0, 0 minus square root of 3, 0 plus square root of 3, minus square root of 3, 0, and square root of 3, 0. Okay. And let's calculate our functions at this point, which is 0. F of 0 minus square root of 3 is minus 3. F of 0 square root of 3 also minus 3. F of minus square root of 3, 0 is 3. F of square root of 3, 0 is also 3. So the largest value in this table is 3, and the smallest value in this table is minus 3. And I can conclude that F has absolute maximum. The absolute maximum value of F is 3, and it occurs at the points minus square root of 3, 0, and square root of 3, 0, which is 3. Okay. And the absolute minimum value of the given function is minus 3, and it occurs at these points, which is minus 3. Okay. So this is the absolute minimum value, this is the absolute maximum value. Also, I can say it like that: F has absolute minimum at this point and this point, absolute maximum, sorry, and F has absolute minimum at this point and this point, and the absolute minimum value is minus 3, absolute maximum value is 3 here. Okay, so this is the end of this video. See you on next week.